Hey guys, Ash here with another episode of the ORT trophy truck build. For those that have been following on, thank you. If you've got any questions about the build, anything at all, post it up in the comments, and we'll endeavour to get those questions answered. If there's anything you want to know about the truck, maybe we can do a video on that. Let us know in the comments. If you haven't already, subscribe, hit that bell button. It helps us greatly for supporting the people that support us. Without our great sponsors like Mickey Thompson and our other supporting sponsors, it'd be almost impossible for us to do this. So give us a sub and be much appreciated. So today I just wanted to go over, I've been tackling the wiring, obviously doing it all myself. Just wanted to show a few different ways that looms can happen, and talk about the main. There's three main looms that you'll see. You've got your standard OME loom. I've got one just around here. Just gotta pull this out. Look here. So right here, this is an OME loom. It's basically single insulated cable, tape wrapped, and that's great. However, it's not really the greatest for a motorsport application because dirt and water can get in there. But it does have some pros. It's really easy to get into. It's just a bit of tape. You can cut the tape back, but doesn't have a great temperature resistance. Doesn't really have any strain relief on any of the cables. So, you know, under extreme conditions such as racing, like high vibration, you can get failed cables where the cores break. And I want to say that the strands that they use in these cables, when you're buying cables, you can get different number of strands, which kind of relates to the flexibility of the cable. In automotive, you want it to be really flexible, so you run a high strand rate. These don't really feel that flexible. They almost feel not solid, but they feel kind of like a 7-strand or something along those lines, rather than a high. Oh, they do have a lot. But anyway, that's a standard OME. I'm sure you've all seen that, right? It's what just about every car is going to have. And then you go from that and you step up to like a Grass Roots Motorsport loom, I suppose, which is more similar sort of concept, where you tape it and you use maybe some split conduit to protect it, but you're probably going to upgrade the cabling to a 115 degree cable. I think it's Tefoil or something like that. I don't know. If I see a receipt, I'll let you know. And then finally you've got mil-spec cabling, which is the duck's nuts. So sorry, going back to the standard OME stuff is only rated to 75 degrees usually, and then you go to the TXL, I think it is, Tefoil, TXL. There's a few different versions of it, but basically that's 115 degrees rated. That's what we're using, and then also the insulation is smaller on this stuff, so it's a bit lighter than the 75 degree stuff. And then you've got mil-spec cabling, which is rated to about 150 degrees Celsius. That is, and that stuff comes with a nice hefty price. It's got thinner insulation again, so not only are you getting a higher heat rating, you're getting a thinner insulation, so you're getting a better, a lighter cable. But to be honest, for the cost of it, it's really, unless you're in like an F1 car where you're talking grams, it's not really to a benefit to someone like me anyway. Someone else might think it's a great benefit, but I'm using the 115 degree stuff because it's like more than double for the mil-spec cabling. And then the whole then with a full mil-spec loom, I've kind of doing a bit of a mix on mine. It's basically a mil-spec loom using the 115 degree cable. I'm using the sealed heat shrink method, but I am cheaping out and I'm not using the T-pieces. So you can buy these heat shrink T-pieces. So when you go to tee off, let me find somewhere where I've teed off. So see just here, you can buy that in like a 3-piece tee where it'll have 1 entry point and 3 exit points. However, those T-pieces are extremely expensive. Like, they're around the $70 to $90 each mark. So I've just been using the Raychem dual wall heat shrink, which is the glue filled stuff on the ends, and gluing right up to the very tips on all the 3 cables in here. So each one of these is all sealed and glued up, and then I'm just putting another glue over the top, and a big one over the top. Obviously it's definitely, it's not watertight, but you know, you're gonna have to hit it with a high pressure hose directly to get water in there. So it's pretty good, I think, for what I'm doing, and I'm not spending another couple of grand on T-pieces, that's for sure. And if I did think about actually going and getting some potting agent, which would make it just as good as a T-piece, and then down the guts, just pot down the guts in there, down the center, put some resin, or you can buy potting agent, and do that, and you know, that's going to make it just as good as a T-piece or a tee-off piece that you can buy, because yeah, they are bloody expensive. So yeah, so that's what I'm doing. So basically how the looms work is there's 2 types of heat shrink. You have dual wall and single wall. We've got lots of heat shrink down here. So the dual wall, is pretty easy to identify. It's always got like a shiny inner, and it's a bit sticky. It's also a lot thicker. And the single wall is really just like your standard heat shrink, you know. It's dry, completely dry. It's thin. It's really easy to bend and move. Generally, the dual wall glue filled stuff will shrink down 4 times its diameter. So this one here you can see is a 16 mil, and that will shrink down 4 times. That will get down to and then what's this one? This, and then your standard stuff only shrinks half its size, right? Yeah, so the main part of the loom we do in the single wall, and then we just use the glue on the ends. The glue stuff is quite rigid, so you don't really get much flexibility there. So you can see in here we've got we come out in flex. I've got one of those T here. I've tried to get the T as high as I can, so if we do have any water, it's not going to get stuck and sit in there. It's going to always fall down with gravity. So this section here is glued. You can see the glue oozing out the bottom, and then all this stuff in here, this is just your single wall. And then another trick which we do is, you can see here, we've actually twisted these together. The best way to do that is to put them in your battery drill, believe it or not. Obviously don't over twist them because you could damage them, but in a twisted state like that, not only is it way more flexible, it's like rope, but it also provides some strain relief. So those cores wrapping around each other are going to assist on some strain relief, and then that obviously will get inserted into some single wall heat shrink all the way, and then the ends will just get glued off, similar to what we've got here. So here you can see this one here is obviously being twisted inside. It's nice and flexible. It's like rope. Right on the end here you can see we've got our piece of dual wall glue, and then I'll fit off my DT Deutsch connector, which is a waterproof connector, and I'll also, you can buy boots for them, but I've got some heat shrink that will fit, and I'll also put a piece of glue filled on the back, which isn't super necessary, but I'm doing it on a lot of my plugs just to keep as much moisture as we can out. So as you can see in here, we've got the PDM all mounted up. This is we've got our feed cable coming in. That's all in there. This cable coming down from the top here. This is our V-neck cable from our switch panel, which is mounted on the roof in the cabin, over near above the driver over there. So that comes in down through here because it had a nice small plug. This cable here, which has the V-neck connector on it, and it also has to have our end-of-line resistor. Originally I had a bulkhead fitting which I mounted in here, and then I couldn't get the B-loom plug in and out. I don't even think I could get it in, so there wasn't enough room in there. So I moved it, and I've now actually got it mounted on the lid, but it's worked out well because what I've done is, where I had that hole, I made up this plate, and it's basically a grounding plate. And if you have a look underneath, you can see in here I've got this negative ground here, which comes to this post here, this grounding post, and this ground here, just, it is, I have taken the paint off and gone back to the frame there, but because the whole frame is powder coated, I'm a bit worried about getting good grounds. So I have run this one back to the back to where the main the solid state isolator is, which is just in here. And I've got this other ground strap which goes across the back of the isolator, and the two main bolting what do you call them, studs or whatever, they're being used as grounds, and the front face of that that isolator, see if I can get a photo of it there, this actually gets grounded. So what happens is the battery ground comes onto the main isolator, onto here somewhere, I can't really see where I'm pointing, and this unit switches that ground and through its body and to the frame of the truck. It also has a designated switched positive with a 40 amp capacity, which you run directly to your ECU, which will be also controlling the injection. So by killing the injection, you will kill the engine. If you kill the engine, the alternator is not going to run, and therefore you're not going to have any power. So then this, and at the same time, by switching the ground, everything else which is grounded to the frame also switches off. But you always run into that issue where if the engine's running, the alternator is still going to be making power, so you need to kill that engine to stop that power from getting made. Damn, this video is getting long. But yeah, so getting back into here, I'm jumping all over the place. But the V-neck cable, this ended up being a grounding post, worked out really well, because now I've come through the bottom, and I'm putting all my small grounds in here. These ones here have got to get terminated yet, but you can see they just get terminated like that. And yeah, this plug has now been moved, and it's terminated here onto the lid. It just looks like that, nice and simple. Basically just a straight through, but it keeps it all watertight. And yeah, so we might leave it there. It's a bit of a all over the place kind of video this morning, but the main points are we're still ticking along. The wiring is very involved. I ran out of heat shrink, so it held me up a little bit, and I've only just got another order in. But yeah, we might do a second part video and continue on with the wiring with that, and we'll go from there. So yeah, again, thanks everyone for watching. If you have any questions about anything to do with this video, with the electronics, whether it be the Racepak PDM, I didn't really talk about that. We'll be running the Mtron KV8 ECU. Got a Racepak data logging dash. They're all talking to each other via the CAN bus. But yeah, if you have any questions about any of the electronics or anything else on the truck, please comment in the comments down below, and I'll do my best to answer your questions, or if it's something big, maybe I can do a video on it, or if there's anything else on the truck that you want to have a look at, we can have a talk about it. No problem. So thanks again everyone. Remember, subscribe, share the video for us, help get it out there, and yeah, we'll see you next week when we put the next one out. Cheers.